All right, now we have the final but hardest job to do, and that is a C statement that contains a for loop. Now on Monday we're going to see for loops that do not have as regimented a segment as this one does, but in each instance of the for loop we need to do a task. That is, read B, read B of I plus 1, multiply it times 2, then store it into A. What we need to see here, though, is that we have a constant. I, of course, is a variable, but it gets set to 0, then it goes up to and including 2. So what's important to realize is that I equals 0, then 1, then 2. We don't have to have a real loop. What we can do is unroll this loop and do something for I equals 0, something for I equals 1, something for I equals 2. So, first, we're going to go, and then I'm going to put in parentheses, I equals 0. So, when I equals 0, we need A of 0 and B of 1. So we need to first load B of 1. We got some trash registers here, R10 through R14. And I is going to be associated with R9, but we really aren't going to have to care about that. So for the part of the loop, this loop executes 3 times. When I is equal to 0, what we're going to do first is load from B of 1. So we need to load into a trash register, let's use 10. And we need B of 1, that's 4 bytes. Beyond base of B, which is in cache 17, or register 17. So, B of 0 is in the address 17. The contents of 17 contain an address. We're going to go 4 bytes beyond that. We're going to have an address, 4 plus whatever is in R17. We're going to go out to memory. We're going to grab a payload. We're going to bring it back. We're going to put it into register 10. Now we need to manipulate it. We're just going to go ahead and use 10 again because it's our trash register. What this does is has B of 0, B of 1 times 2. That's in R10. Now we need to store it back. Store word. 10 now is an argument. Let's write that a little bit more clearly. Register 10 is going to be used as an argument. Now where do we want to put it? A of 0. So we're going to put 0 here. And where do we put it? Not in B's array, but in A's array, 6. All right. Loop goes through. I equals 1. So we have, again, load word. Let's put it in 10. 10 is just going to be thrown around like a sailor going from port to port. So, load word into 10. Now, we need B of 2. Because I is equal to 1, we need B of 2. So that's going to be the constant 8 and the base B, which is in 17. I'm going to do the same sort of thing. We're going to double whatever contents were in the memory that got loaded into 10. Now we're going to store it back. And we need to store it. What payload? 10. 10 needs to go out to memory. We've doubled it. So 10 is our source. Where do we want to put it? I of 1 or A of 1. So we need 4. Not 1, 4 bytes beyond the base of A. What is the base of A? That's going to be stored in good old register 6. Loop goes through. Now, the last one, I equals 2. And after I equals 2, this is the last thing we need to do because then the loop ends. The loop goes 0, 1, 2. This is our last job to be done. The load word. Oh, poor 10. It just keeps getting used and used. So, do we need I of 2? No, we need I of 3. 3 times 4. Okay, just a second here. You know, I don't have my phone with me. I have to work this out. 3. 3 times 4. I'm gonna have to take my shoe. Oh, that's 12. Okay? 12 beyond the base of B, which is in 17. Then we need to double it. Poor 10. Getting used and used and used. Don't make me make a joke here. So, now 10 contains whatever was in B of 3. 3 times 4 equals 12. We doubled it. Now we need to store it back. Last instruction. Take a deep breath. Here we go. 10 is the payload. We want to go out to memory. Where in memory do we want to go? We want to go A of 2. A of 2 is going to be 8 bytes, so we're going to put an 8 here. And then where is the base of A? Good old register 6. And we're done.